Let's go through LeetCode 2952. Minimal number of coins to be added. For this question, it gives us integer array coins and integer target. And we return the minimal numbers of coins of any value need to be added to the array so that the integer in the range 0 to target is obtainable. And we have target smaller equal to 10 to the power 5, right? So what we're thinking about is that we can set a variable called current, which represent the maximal number, which is obtainable so far, right? So let's set this one is 0. So what we're thinking about is that this coin, right, we should have a sort, right? Otherwise, because we want to see whether this current already covers these coins, right? So if at the beginning is, a bigger number, of course it will not cover. But if it's smaller one, right? So it's possible it's already covered, right? Then we can use these coins to add some bigger number to our current. So these coins should be sort. The first thing, right? So let's look at the example, right? So current is 0. That is our current maximum number we can cover. And we'll say there is a coin 1 here, right? Coin 1. 1. Let's say this we can add to current. You'll see 0 and 1 is consecutive, right? So that means for this kind of scenario, we can use this coin. So now our current will cover 0 and 1, right? So that the maximum number will be 1. And the next coin, it is 4, right? The 4. So what we cover so far is 1. And if we don't want to add or patch some kind of number, the next coin should be 2, right? So that we can be consecutive. So that means the first gap of the number we cannot cover obtain is 2, right? So what we think about is we add a number 2 here. So in this case, how many coins we need, which the counts should plus 1, right? And now because we add a 2 here, so the maximum obtained current number becomes 3, right? 3. And we look at the coins. 4 is equal to 3 plus 1, right? That means we can use this coin. That means now if after we use this coin, the max obtained number we get is 3 plus 4, that is 7, right? And then the next coin is 10, right? So the things that we'll see, there is some gap between 7 and 10, right? That means this 10 we cannot use this coin directly. So what the next missing number of the gap is what is 8, right? So we should add 8, right? So a moment ago we patched the 2, right? Patch 2, and now we add 8. So if we add 8 here, the maximum obtainable value we get is 15, right? So let's see, 15 is greater than 10, right? So that means we can use this coin to patch to add our maximal obtainable result. That means if we use this, the maximum obtainable value will be 25. You see, this 25 is already greater than 19. Then we can terminate. So so what we need to add is number 2 and number 8, right? So just we should simulate this process and write this as code. So let's begin to write code for this. So what we need is we are going to have a current, right? Current will be the maximal obtainable number we have, right? So let's set this one as 0. We have thought these coins, right? Coins. And let's have the index of a coin will be 0 at the beginning. And we have result, right? Result equals 0. So we'll say, wow, this current, the maximum obtainable number is smaller than target, right? So we should still do either picking a coin or patch a number, right? So in this case, we have 2 scenarios, right? The first thing is that if our coin is used out, right? So if the index is equals to coins dot length, then we have a hard to patch numbers. Or coin index is greater than current plus 1, right? So means there is some kind of gaps. Then we are patch what? We are patch up. That means the next gap missing number is current plus 1. So our current plus equal to current plus 1, right? And we are at patching one number, right? So result will plus plus. Else we can use a coin. So the maximal obtainable number will plus equal to coins index, right? Then we move one more index for the coin, right? So this will be, then we return result, right? So this will be the time complexity is O coins length, right? In log and